Hello guys, welcome to my YouTube channel. So today we still treating what's calculus 1.0 and other calculus we're treating differential calculus. Before I start, don't forget to get down our dance intro because math is fun, math is easy, and that's why I'm here to tell you guys that math is fun and easy with me taking you guys in this aspect. Let's go.
Graduate, bang. I said it down and he left. A man from and stand. I said it down and he left. Graduate, bang. I said it down and he left. Graduate, bang. I said it down and he left. A man from and stand.
Okay, enough of the dance. Okay, now marginal cost. On the board here we have the cost of producing X items is C of X is equal to 5x squared plus 2x plus 100. Find the imaginary cost when 10 items are produced. Very, 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 very simple. If you're given a question like this, how do you approach this? How do you solve this? You're given a question like this. It's very, very simple. Don't panic. Don't panic. It's just calculus. And it's just differential calculus. It's just too much English. Okay? You know, with our mathematicians, we don't like English. It's just too much English. But I'll break it down for you guys. I will break it down. Now, let's get to it. Solution. Now, I want to find the word imaginary cost. Imaginary cost is the derivative of the cost of producing, like the cost of production. Now, we have to find the imaginary cost. Imaginary cost is equal to derivative of cost of producing, derivative cost of production. Okay, derivative cost of production. That is the imaginary cost. And derivative cost of production is given as C of x, C of x to be equals to 5x squared plus 2x plus 100. Okay, now because we're asked to find the imaginary cost is derivative of the cost of production, and this is the cost of production. We're going to find the derivative of this, and we're going to have this to be c prime of x to be equals to, remember the power rule. We are differentiating the power of the variable here, which is what 2, multiply the coefficient of that variable. So we have 2 times 5, and we subtract 1 from the power of the variable. So we have x to the power of 2 minus what 1. Do the same thing to the next term. So we have plus the power of x here, of 2x here is what 1. So we have 1 times 2, and we have x, the power of x is what 1. I'll subtract 1 from it based on the power rule. And remember when I told you guys previously that if you're differentiating a constant, if you have f of a constant, that f of x is equals to what 100. Based on this now, we have f prime of x is equals to 0. Whenever you're differentiating a constant, is always 0 anywhere. You know I love math. Math is very, very simple. It's unique. It's like it doesn't change. Okay? Now we have this to be plus 0. Okay? Now we have this to be 2 times 5, which is 10. So we have 10. Then x to the power of 2 minus 1 is what 1. So x to the power of 1, which is tx. So 10x plus 1 times 2, which is going to give us 2. X to the power of 1 minus 1 is what x to the power of 0. And based on laws of indices, when you have x to the power of 0 is equals to what 1. Any number to the power of 0 is what 1. So we're going to have this plus what 2. So we have 10x plus 2. Are we stopping here? No. If you're watching to this end, don't forget to subscribe if you're not subscribed yet and give me a follow. Now now we have 10x plus what 2, and it said find the imaginary cost when 10 items are produced. So now when 10 items are produced, we're going to have this to be c prime of 10, because x here stands for the items. Okay, c prime of x of 10. Wherever we see x, we put what? 10. So we have this to be 10 multiplying by 10 plus 2. 10 multiplying by 10 plus 2. Very, very simple, right? 10 multiplied by 10. 10 multiplied by 10 is what? 100. So we have 100 plus 2. We're going to give us 100 and what? 2. 102. So the imaginary cost is 102. Okay? Now this is our imaginary cost. This is our imaginary cost. Okay, if you want to get to the end, don't forget to subscribe and give understand. I'll see you guys in the next video.